Okay, so here's how you solve this problem. You bring it up here, x squared minus 2x minus 120 equals 0. Okay, so how do we go about, in fact, actually, let me bring it down where there's a little more room so we can work on it with a little more space. There we go. Okay, so question number 1. So how do we actually handle x squared minus 2x minus 120 equals 0? Well, what we need to do is we need to factor. Now, the way factoring works, you might be a little rusty on factoring. That's okay. I'm glad to go over everything. And so how factoring works is you put x's right here and here. You might remember a little bit of this. And you're looking for two numbers that multiply to be 120 and add or subtract to be the minus 2x. Like that. Then you got to take that sign. So multiply to be negative 120 and add or subtract to be negative 2. That's the two numbers that will go here and here. Well, how do you find those? Well, you just got to start guessing around with your calculator. So take the minus 120. Remember, let me get a little more room there. Take the minus, you want two numbers that multiply to equal minus 120. What could that be? Well, just take your calculator and just go, 120 divided by 4. And for example, you'll get 30. So then you go, oh, okay, well, like 4 times 30. Now, what about the negative? Because that would be positive 120. Yeah, I know. Don't worry about the negative right now. We'll get back to that. Let's get some other numbers. How about divide by 3? Then you'll get 40. So you go, oh, so then 3 times 40 is another pair. Right. Okay, divide by 2. You get 60. So that means 2 times 60. Just use your calculator. You can use calculators on tests and everything. What else? There's probably got to be more. How about 2, 3, 4, 5? 5, what's that going to be? I think 24. I'm just going to write down a bunch of these. 5 times 24. How about 6? 20. That means 6 times 20. So I'm just taking 120 and I'm dividing by different numbers, kind of at random. You try 7 and it'll say no way. You give some decimal. Decimal doesn't work. Divide by 8. 15. It's probably enough. I don't know. Now, how do you know what? Well, they have to add to be negative 2, right? Remember that's right here. Add to be negative 2, multiply to be negative 120. The number at the back is what they multiply to be. The number in the middle is what they add to be. So which ones add? Which one of these numbers? Are any of these numbers separated by 2? No. Maybe I better do more. Okay, divide by 9, it's just a decimal, I think. Yeah, divide by 10, oh, there it is, 10 and 12. 10 and 12. That's the pair that can do, now why? Why do I know 10 and 12? Because they're only apart from each other by 2. So in other words, do you see if the 10 is positive and the 12 is negative, then they'll multiply to be negative 120 and they'll add to be negative 2. That's my pair of numbers, positive 10 and negative 12. Do you see how I came up with that? Do you see how I knew it wasn't any of these? Because all of these are further apart than 2. So there's no way they could subtract. When I say add, I really mean subtract, right? When you add a negative, that's subtract. Same thing, basically, right? 10 minus 12 or 10 plus negative 12, whatever. Either way, it's negative 2. Same thing, huh? So basically, I'm observing that, okay, 10 and negative 12 are my two numbers. So I bring them up here. It doesn't matter what order, plus 10, minus 12, or vice versa. You can put them in you can put the minus 12 first and then the plus 10. It doesn't matter. The order doesn't matter, but the signs do matter. The 10 has to be the positive one and the 12 the negative. Why? Because that way it comes out negative 2, which is what we had in the middle, negative 2. Is that making sense so far? See how I'm coming up with that? So, okay, but we're not done yet. We're close, but we're not done yet. So what this means is we've found how we found a couple of numbers, something that will multiply to equal 0. So we've taken this right here and we've factored it like that. That's called factoring. Now let's check it. This is the most important thing. You might feel like it's a waste of time, but I think it's valuable. Let me come over here and let me check. We're not done yet. We're not totally done. We're close. But let me stop and let's check down here. I'm going to check that x minus 12 times x plus 10 is really the right. This is called a factoring check. Did we really factor it correctly? This is very important that you learn how to do this, to check. So how do you check? Remember how to multiply two parentheses? It's called FOIL. The first one goes to both of the other two. So x times x, remember that's x squared. And then x times 10 is plus 10x. And we also call that FOIL, FOIL. That stands for the front times the front item times the front one. The O stands for the two outside guys, these two outside guys. The I stands for the two inside guys, minus 12x. And the L stands for the last with the last, which would be minus 120. Now, I probably was confusing because I said that two different ways. Let me say that again. I like to basically just say the first guy goes to both. X times x is x squared, x times 10 is 10x. And then he's done, and the second guy goes to both. Minus 12x minus 120. Does that make sense? It's just they take turns. First to both, second to both. Or FOIL, same thing. FOIL is another way to say the same thing. Now why am I all into that? Well, that's how these guys multiply. Well, so what? Well, now we can combine terms. See how these two in the middle combine? Plus 10x, oops, get my pen here, plus 10 minus 12, that's the minus 2x we were looking for, remember? And there we go. What do you mean, there we go? That is this. It's what we started with. You see? X squared minus 2x minus 120. So my point is, we're not done yet. We're only one step from the end. You might think that's a big waste of time. Well, I'm just trying to prove that these guys, if you multiply them out, really are the same as this. We haven't changed anything. We just factored it, which means we unmultiplied it. We found out what would multiply to go back. That's what this all was about. You see why that multiply add thing works? Where did that minus 120 come from? These guys multiplied, didn't they? 12 times 10. Where'd that minus 2 come from? These two guys added, subtracted, 10 minus 12, right? That's why from the beginning I said we're looking for two numbers that multiply to be minus 120 and add to be negative 2. The middle is always what comes from adding, and the back number is always what comes from multiplying when you FOIL, when you do first to both, second to both. That's just what happens. Okay, great. So let's finish up the problem. Where do we go from here now? You take the first parenthesis and you set it. So step one, this was step number 1 here. And then step 2, each parenthesis equals 0. So that means I'm going to take the x minus 12 equal to 0 separately, or the x plus 10 equal to 0 separately. Does that make sense? I set each one equal to 0 step separate. That's step 2. So step 1 is to factor. Step 1 is to factor with the parentheses, like we did right here. Step 2 is each parenthesis equals 0 separately. Now, why can we do that logically? Why is that true? Again, I want to give you the reason so it'll stick with you better. That's because two things are multiplying to equal 0, so either one can be 0. In other words, what if I said, hey guys and gals, I'm thinking of two numbers in my head, and I'm multiplying these two numbers, and the answer's coming out 0. Well, what do you know? How can you multiply two things and get an answer 0? One of them's got to be 0, right? The first one could be 0. 0 times anything would be 0 or anything times 0, right? The first one could be 0 because 0 times anything would be 0, or the second one could be 0. That's just logical, isn't it? If you're multiplying two things and the answer is coming out 0, that means the first one could be 0 or the second one could be 0. Well, that's what we just did here, right? That's what this was saying. It was saying something multiplied by something was equaling 0. You see that? Right? Two parentheses, that means multiply, was equaling 0. What does that mean logically? The first one could be 0 or the second one could be 0, right? That's only reasonable. And now you just finish solving each one. Let me put step 3 here. Step 3, solve both. Solve both. What do I mean solve both? Well, you just take the x minus 12 equals 0 and the x plus 10 equals 0, and you finish it up. So what do we do here? We add 12. Remember how you do the opposite? Because the equal sign is like a wall of separation. That gets x alone plus 12. That's why it comes out the opposite sign. Does everybody see what happened there? And then over here, you've got to subtract 10 from both sides, right? That gets rid of this, and x is alone minus 10. Those are the two answers. So the answers are 12 and minus 10. They actually end up being the opposite of the two numbers we had up here in our factoring. Everybody see that? Right? It's always going to work out that way. The numbers you have in your factoring, the minus 12 and the plus 10, end up being plus 12 and minus 10. Why? Because when you set each one equal to 0, to get x alone, you've got to do the opposite. To cancel out the minus 12, I had to add 12 to get x alone to both sides, right? Whenever you solve an equation, an equal sign problem, you do the same thing to both sides, don't you? So I had to do the same thing to both sides to get x alone. If two things are equal and you do the same to both sides, they're going to be equal afterwards, right? If two things are equal and you treat them the same, they're going to be equal when you're done. That makes sense. So I added 12 to both sides to get rid of that so that x could be alone. That's what it means to solve for x, get it alone. And the other side became 0 plus 12, positive 12. Over here, I had to subtract 10 from both sides. X is alone, 0 minus 10, negative 10. So my two answers are 12 and negative 10. Let me put a box around that. So there it is. And we have solved it by the factoring steps. That's what it takes to solve it.